Hey there, I'm Bruce from DAS42. I'm a principal consultant. I've been with the company for about 6.5 years, and today we're going to be talking about a new solution that we're bringing to market called MDM42. To tee this up a little bit, a really common problem that DAS42 sees with our clients and just the overall data landscape is that data for critical quote-unquote business entities is typically scattered across dozens of systems with no formal foreign key relationship. I think probably the principal example of this is customer data, but depending on your industry, it could be, things like organizations, devices, locations, content, ads, you name it. These core entities is really what we're talking about here. And customer data is maybe the most relatable and easiest to tee up. You've got a CRM that says Mike Johnson, an ERP that says Michael A. Johnson, and your billing system shows M. Johnson at a slightly different address. And all three systems have phone numbers and emails in slightly different formats. And our human brains can see that they're the real person. They're the same real world person. But getting a machine to agree is actually surprisingly challenging. And then you multiply that by thousands of customers, and you've got this data quality nightmare that can cost real money. Duplicate mailings, conflicting customer histories. This is all going to lead to this disjointed customer experience. And internal analytics that you simply can't trust. Traditional approaches to this problem can be painful for a variety of reasons. Manual deduplication, format alignment, and clustering simply doesn't scale. Rule-based matching misses variations that are obvious to humans, like nicknames, typos, or different formats. And building a custom solution in-house takes months of engineering effort. And off-the-shelf MDM solutions are usually complex, expensive, and can be difficult to integrate with your data platform. This is where we feel that MDM42 really comes in. MDM42 is a master data management solution that is containerized to run natively in Snowflake on Snowpark container services. It uses AI-powered matching to find duplicate records across your source systems and automatically creates clean, authoritative golden records that get written straight back to Snowflake. So let's talk about how it works. The workflow is fairly straightforward. We connect your data sources. Basically, we point MDM42 at CRM, ERP, billing, any other table that you've ingested into Snowflake. Then we do this intelligent matching where we use vector embeddings and cross-encoder AI models to find records that represent the same entity, even when the data doesn't match exactly. Then we perform a clustering task where related records are automatically grouped together. And this is a transitive match that allows us to identify if record A matches to record B and record B matches to record C, then we know that record A should also match to record C. And then finally, we do a golden record creation where for each cluster that's identified, MDM42 can apply survivorship rules that you configure to produce a single authoritative golden record that will live right in Snowflake. So let's talk about what makes MDM42 different. It runs in Snowflake. Your data never leaves your environment. So we're bringing the code to the data as opposed to the data to the code. We use AI-powered matching that catches variations that rule-based systems miss, things like nicknames for Mike versus Michael, typos, formatting differences, even records with different email addresses but matching names and phone numbers. We have configurable survivorship rules, so you decide how to build the golden record. Most complete value, most recent, source priority. We support 11 different survivorship strategies. And finally, it's fully automated. You can use the scheduling system, which creates native Snowflake tasks, to schedule the entire workflow to run on a cadence right within Snowflake. So to tee this up, I'm just going to look at the data that we already have in Snowflake. So like I mentioned, we've basically got these three systems, a billing, an ERP, and a CRM. And I've set them up in Snowflake to be a common schema. This isn't required, but it certainly helps as I push it into MDM42. But I have three different tables that have basically the same columns. I'll have a source ID, a name, an email, a phone, and an address. So I've got one for my billing source, one for my ERP source, and one for my CRM source. And this is obviously demo data, but the idea is that we're going to have little nuances across all of these systems in people's names, in their email address, in even their phone formatting, things of that nature. And we're going to be able to see as we go from kind of these three disparate systems, we will work through MDM42 and we'll see that these differences across these data sets are formalized and consolidated. And we also are able to say that, hey, Michelle Craig is the same Michelle Craig in this system as they are in this system, as they are in this system. And if we don't find matches across all three of those systems will still reflect that individual. They're still a valid individual in the system. They'll just show up as like a singleton is what we call it. So now I'll go ahead and jump into the actual MDM42 tool. Like I mentioned before, this is a fully containerized application that's running right on Snowflake compute. It has a React front end and a Flask back end, but everything that we do and touch and work with in this application under the hood is firing Snowflake jobs. So put another way, 100% of everything that you're about to see is running in Snowflake, moving data through Snowflake, landing in Snowflake, running on Snowflake compute, the whole 9 yards. So as we work through this flow, the first thing that we need to do is embed our data set. So like I mentioned, this is a machine learning and AI forward algorithm that's essentially running in the background. So we've got to do some machine learning and AI forward things up front. So the point of the application is to really guide the user through some complex things and frankly make it simple for them to do very complicated matching algorithms all in Snowflake. So let's get started. I'm on my embed task here. The first thing that I need to do is I need to tell it where is the data that I want to input to the MDM. So I know that I've saved the 3 data sets that I just shared in this database and in this schema, and I'm going to go ahead and add each one of them all at once to my MDM. So go ahead and get those nice clean visualizers, and I can see that all 3 went through. I also have an opportunity to customize the quote-unquote canonical fields that are going to live and ultimately be materialized on my golden record. So you might be able to quickly see how this could scale to really any use case. Right now it's pre-configured to work really well for people, but you could change these canonical fields to things like address, organization name, device name, serial number, whatever your use case is. The algorithm is sort of agnostic to the entity that you're matching. In this case, we're doing a person matching use case. So I care about things like their name, their email, their phone, their address. Those are the types of things that I really care about mastering and having on my gold record. So I've configured my canonical fields as such. Then I can see that these 3 data sets have all been pulled in, and the application is smart enough to realize that there's an auto match between, if there's a column called name on one of these tables, then it should automatically match to the canonical field called name. However, if I had named it something slightly different, I as a user could come in here and actually do the mapping myself. So it can be done. I've just kind of cleaned things upstream to make it easier on myself in the demo. So I've got my 3 data sets. They're all nice and green and showing that they're ready to go. And now I can assign column weights to each one of those 4 columns to help inform how the match should be weighted effectively. So in other words, if I wanted to put a heavier weight on email and phone matches than say a name or an address match, I have the ability to do that right here. So as I've been testing with this particular data set, I've found that a nice healthy mix of weights is essentially this. So 40% email, 30% phone, 2% name, and 1% or 10% address. And this was a 20% for name. I misspoke. So I'll set those weights, and then I'll go ahead and configure the warehouse in Snowflake that should actually perform this compute. And I'm going to give it an output file prefix. And this is important because it's going to, as you'll see potentially downstream, what you'll see is that this person prefix is going to help auto-populate a bunch of the downstream configurations. So this is really just a helper for the user. And then I'm going to go ahead and execute my embedding. And once I execute the embedding, my little job activity tray is going to pop up. And after some waiting, it will show me visually that that embed job is running. And behind the scenes, what we're functionally doing is translating these human readable strings to arrays, basically vector arrays that a computer will be able to do really fast math on. So that's the process of embedding, and we have to be able to set up some really fast math for the matching algorithm to work. It's worth noting that when these jobs are running, I can actually view the logs myself. So I can get a nice clean output of basically here we are like installing the models and loading all of our weights. And now by column, we're going to encode the name, the email, the phone number, and the address one by one by one. And as a user, I can just kind of watch this and visually see that this task is being accomplished. By default, the application is set up to sort of auto refresh every 5 seconds. So I'll just keep an eye on it and let it do its thing. And once it's complete, it's going to write the embedded data set back to a Snowflake stage so that I can use that embedded data set in a downstream task. So here we have some stats about what we've just done. We basically took data from our billing source, our CRM source, and our ERP source, smushed it all into one common embedding, and then one common table, I should say, and then we encoded each one of those columns that were configured. Now I can move on to what is the next step, which is our index task. So I mentioned before that person prefix that I called out was important. And the reason that's important is I can simply just type person, and then the application is smart enough to kind of pre-populate a bunch of the other file names for me. And we'll see this continue as I step through each kind of formal step in this process. Is person is just going to kind of pop up for me and make it really easy. So now what we're doing is creating what's called a FAISS index. I don't have time to probably properly articulate exactly what's going on here, but this is a key data structure that's going to help us run a really performant all-to-all match coming up shortly in our match step. So I got to create this index. And like I said, once I trigger the job, I can see and visualize and monitor the process of said job. I can check in on the logs, make sure everything's looking good. So I'll do that here and let our index task work through, and I can see that it's writing my file back to the Snowflake stage, and now the task is done and I'm ready to move on to my next step. So now I'm going to configure what's called a FAISS match, which is going to use the index in our previous embedding to do a really, really performant all-to-all match. So every single record is going to be compared to every other record, and we're going to find the top K nearest neighbors, and that's going to be a really fundamental part of our gold record identification. So again, I'm going to use the helper kind of person suffix that we configured earlier, and I'm going to click that button, and it's going to kind of auto-populate really everything that I need. I can configure a couple in the weeds parameters, like how many top K nearest neighbors I get to pull through. Like right now, it's going to, for every single record, it will find the 3 most similar. If I wanted to be more aggressive and cast a wider net of potential matches, I could just bump this number up. I can also configure some kind of performance tuning, if you will, where I can set a baseline similarity threshold that a match must meet in order for it to make it to my next data structure. So like what I'm essentially saying here is that the strings that I'm comparing have to be at least 50% similar in order for them to make it to the next step as a valid match. So I'm going to keep the config as kind of default for now, but the user would have a lot of different knobs to turn for any given use case that they're working on is the main call out here. So I'll go ahead and execute my match, and we'll walk through kind of the same process as before, where I can visually monitor that task. And I haven't talked a lot about what's going on behind the scenes here, but there's essentially another containerized service that's running that holds all the logic for this matching algorithm. And as we step through each distinct part of the MDM workflow, we're triggering a different job service, actually. So I could even show the SQL that is really running under the hood. Again, everything is on Snowflake. So what we're actually executing here is SQL that is executing job services against a completely different containerized image that we've deployed that's doing all of this complicated matching, but it's taking these inputs and outputs and making them really native to Snowflake effectively. We're taking a table as an input, we're putting a file and a stage as an output, for example. So our match task finished up, and I'm just going to keep chugging through to my next step. The application is going to do a lot of the filling for me because of that person prefix. But now I'm at a really core part of the MDM42 workflow, which is our cross match. So up to this point, I've described a little bit about how we've done this all-to-all match. And I basically have, for every record in my initial embedded data set, I've got the top 3 closest neighbors, which is valuable, but it's not the full story. Now I really need something to comb through and semantically compare. Is John Smith, or is Jane Doe, Jane Doe? And we're going to use a technology called cross-matching and cross-encoding to perform this match, to perform this scoring, if you will. So the first thing that I'm going to do is tell the application which columns I want to include in my cross-encoding. So in this case, it's going to be our name, our email, our phone, and our address. And so effectively what we're going to be able to say is, hey, this cross-encoding algorithm, I want you to semantically, just from a semantic perspective, tell me how similar this person's name, email, phone, and address is to this person's name, email, phone, and address. I want you to assign it a score from anywhere from 0 to 1. 1 being absolutely, these are the same person, and 0 being absolutely not, these are not the same person. That's what we're accomplishing with this step. So I can also At that same time, I can, for what it's worth, I can change my cross-encoding model to accomplish different types of tasks similar to an LLM, or when you're working with an LLM, you might pick a different model based on the type of work that you're doing. The same is true with cross-encoding models. Some of them are really good at semantic matching. Some of them are really good at saying, is the answer to this question in this document? So there's vast use cases when it comes to MDM42. We support a lot of them, is the upshot there. The other thing on the cross match is you can insert some hard and fast kind of like trump rules. So right now we're basically saying like, yeah, if you semantically think that these are the same, then they're the same and mark it accordingly. But for people, I know, as a human being, like I know that it's a very low likelihood that if you have the exact same email address as some other person in some other system, you're probably the same person, right? So I'm going to create a couple hard and fast trump rules with these deterministic rules. And I'm going to say that, if I get an email match that's one-to-one case insensitive, we're going to go ahead and say that that's just an auto match. You don't have to do all this fancy cross encoding. And I'm going to do the same thing for phone number. Go ahead and add that rule, and then we will execute our cross match. And this is the most computationally expensive step because we're literally going row by row by row by row by row to semantically ask like, hey, are these things the same? So the overall architectural premise of this algorithm is use the FAISS match to do this massive all-to-all comparison really, really fast, really, really performantly. It will scale to the millions of records, and it will do it really, really fast. And what we're doing is doing this giant all-to-all to make our problem set much smaller. We go from like every record to now every record to just its top 3. And then the thinking is, okay, well, now let's use these really intelligent cross-encoding models to take us that last step and say, okay, functionally, we found mathematically that this record is the most similar to these other 3 records, but now I want this cross-encoder to do that last mile and basically say, okay, really, who is most similar? Semantically, are these actually a match? And you basically make this really big problem a lot smaller. But that said, we're still looping through every single row at this point. At this scale, in the thousands of data and thousands of rows, cross-match it doesn't take that long, probably a minute or 2. But obviously, as you continue to scale, this process in particular might take a little bit longer. And there are strategies for speeding it up that DAS42 would love to talk to you about. But for the demo, we'll have to sit here for a couple more minutes and let the cross-match complete like it just did. So now, effectively, like if you're kind of keeping a track on what we've done at each step, I'm now at this point where I have a data structure in a Snowflake stage that is every single record across all 3 systems. For each one of those records, I have the top 3 most mathematically similar records. And now, after the cross match, I have a cross score across every single one of those rows that basically says from 0 to 1, how confident am I that these 2 entities from a semantic perspective are the same. And what we can finally do is, well, I shouldn't say finally, this is the second to last step, is we can cluster. And this is going to use basically a graph-based approach to accomplish what is called a transitive match. And what I mean by that is if we're seeing that, person A has a really high confidence match with person B, and then we're also seeing that person B has a really high confidence match with person C, well, we can intuit from that means that person A should also match to person C. So that's what the cluster task is doing behind the scenes. And again, I just pick person and it kind of figures it out for me. And this is really, really fast. Behind the scenes, we're using, like I said, a graph data structure to kind of traverse all of our clusters and intelligently decide what should be matched together from a cluster perspective and what should not be matched together. And once we've done this job, we have to do some final MDM specific configuration to set up survivorship rules. So that's what we'll do in our gold record. So I'll jump over to our gold record and I'm going to hit person and it's going to fill everything out for me. But now I'm at this point where, because everything's in Snowflake, nothing has ever left the ecosystem, I could very easily also write it back to Snowflake. This final gold output, the thing that we really care about, I'm just going to run infinite improbability drive. I'm just going to write this right back to the same database and the same schema that my input data set was. And I'm going to call it person gold record. And I have to configure some survivorship rules. So the thinking here is that maybe John Smith was in all three systems, and that means that I really have three options for their name, their email, their phone, and their address. So survivorship rules is where you tell the system how do you source these key attributes when you've found multiple matches for a given entity. So I can configure them one by one. I could say for a name, I want it to be the most complete, but we support over 10 different strategies. I'm coming up on time for the demo, so I can't spend a ton of time talking about each one, but we would love to have a conversation about your use case and how we would tailor this to essentially be the right strategy for you. The simplest is most complete, which is just, at the end of the day, it's just the longest string. I'm going to use most complete for the sake of the demo, but just know that there's much more that you could do to be intelligent about how you pluck from the final record to get that gold record. For example, you could use like a source priority, where in order of descending order, you'd say, well, I want to take their address, because I know that maybe address attribution is really, really good in the biller, but it's not very good in the CRM. So you could assign a source priority of like, take the biller if it's there, take the ERP if it's not. If nothing else, we'll take the CRM. It would be another example of a survivorship strategy. I'll go simple and just say most complete here. I'll add all four at a time, and then I will execute my golden record, and we will be just about wrapped up here. There's a couple other bells and whistles that I want to show, but we'll get the gold record materialized and then take a look at that final table in Snowflake, and then we'll hop back into the application and show a couple bells and whistles from a scheduling perspective. Okay, so the gold record has completed. It took about 20 seconds. I can take a look at the logs like I have been before, and I can see some really interesting information that kind of speaks to some of the previous steps, where what we had going into this is we ended up with 4,545 total clusters. That came from the 8,000 total records. So in that previous cluster step, we basically took 8,325 records and we put them into 4,545 distinct clusters. And so what that really means is that you really are creating 4,545 distinct golden records. And you're going to have some of those are going to be merged records across all of the systems, but some of them might have only existed in one platform, and that would be called your singleton. And so we basically take all that data, and you can see clearly that it just wrote those golden records back to this table in Snowflake. So now I'm going to jump over to the worksheet that I was in before, and I should be able to query that table, which is called person golden record. And we can see, here's an example of the old schema, right? We have this exact schema for each system. Now it looks like, well, in the gold record, it looks like this, where I've assigned a unique GUID. I've got some metadata tracking around when they were created, last updated, how many sources they were present in. I have an array that I could traverse in downstream gold modeling if I needed to join back to the actual source system for additional attribution. But this basically says like this person was in this source at this ID. They're in these three distinct data sources, and then we will have their actual attribution. There's some more metadata that I glossed over, but nothing super crazy there. Whether it's a singleton, whether it's brand new, how did it get matched? What was the match reason for auditing purposes? And then the final gold attribution, right? Their name, their email, their phone, and their address as dictated by the survivorship rules. You'll also notice that in route, as we moved through that MDM process, we've done a lot of standardization, particularly on the phone number. That used to be kind of all over the place, and now it's in a standard format. So all that to say, what we've done is mash all of these records into a single person golden record by clicking a few buttons. A lot of complicated things happen behind the scenes, but we've kind of made that simple with our containerized application. The other big thing that I want to call out before we wrap up this demo is that oftentimes gold record is a constantly living, breathing thing. You get more users show up in different systems over time, and you want to be constantly checking in on that. That's where the schedule piece comes into this. So I already have a schedule configured from just previous personal run-throughs of the demo. But if I wanted to, I could actually completely wipe that away. And the application is essentially smart enough to know what the current configuration is. So you can see I've got these nice clean green bubbles. If anything was misconfigured on the previous steps, that would show up in red, and I'd know as a user that I have to go back and fix something about the configuration. I also glossed over as I built these intentionally that almost all of these tasks have an incremental mode that I can toggle on. And basically these are smart enough to only run net new embeddings, net new FAISS matches, net new cross matches, net new clusters on data that just showed up since the last time that the algorithm ran. So it's really simple for me as a user if I wanted to set this up to just constantly stay in sync as those tables that I mentioned upstream that we inputted, if those are changing under the hood, maybe every day, I can just come in here and configure all of my steps to be incremental. Cross matches is actually one that is not compatible with incremental. It doesn't make sense to do it because the upstream inputs and outputs were already trimmed is the gist. So I just have to make sure that I've got incremental mode on everything that supports it. And then I can go back into my schedule and I have the ability to create a brand new schedule. So I'll call it, my customer MDM daily. And I'll go ahead and I have a number of options. I'll go ahead and do a cron schedule for this guy and I'll deploy that to Snowflake. And behind the scenes, what this is provisioning is Snowflake tasks that call in the correct order all of the tasks that we just walked through from an embedding or from a user standpoint. It will be pre-configured just the way that I configured it in the UI, and there'll be a task that runs for each distinct step in the right order on this schedule. And I can even come back and monitor the history of these runs. I can see a graph-based visualization of exactly how these tasks work. So right now it's showing this clean yellow bubble that says, yeah, I'm scheduled to run at, 02 *** cron UTC. When the task is actually running, if I turn on the auto refresh, I can see those tasks churning through and I can view the running logs just like we did. You'll see the exact same UI that we saw when we stepped through it manually. So what this means is that all from this single hub, you can configure a really advanced algorithm that absolutely accomplishes this concept of generating golden record from disparate systems. And you can schedule it so that it stays in sync and stays golden over time. So if this is something that you're seeing and you think would benefit, your organization would benefit from using something, or you have a master data set or a data set that you need to master, or data that you want to create as gold, reach out to DAS42 because we can use this to get there really, really fast. And so we'd love to have that conversation. Thank you for your time.